The topic is finding limits of functions of two variables. So let's do the first example. Evaluate the limit of 1 minus 3xy over x squared plus y squared as xy approach 1, 2. So let's look at the definition. F is continuous at a the point AB if limit of f of xy as xy approach AB is equal f of AB. And also polynomials and rational functions, we know they are continuous on their domain. What this says, if I call this whole quantity f of xy, what it says, if let's find the domain that we're talking. So the domain will be what? All the xy's, it's a rational function such that the denominator is not equal 0, which means you don't want x to be 0 and y to be 0. So the domain will be all the real numbers, not the real numbers, R2 minus the point 0, 0. Right? Now, this is our AB in the definition. So since 1, 2 is in the domain, therefore, all we need to do, a limit of 1 minus 3xy over x squared plus y squared as xy approach 1, 2 will be equal to f of 1, 2. What does that mean? All it means is just plug it in. So 1 minus 3 times x is 1, y is 2. X squared will be 1 squared, and the y squared will be 2 squared. So in other words, plug it in. If you get a number, you're done. So that would be 1 minus 6 over 1 plus 4 minus 5 over 5. So the answer would be negative 1. Same thing for this example. It's a simple one. All it says, since this is a polynomial, all it says, polynomials actually, the domain will be r squared. You can plug in any xy. So the domain is R2, so all we need to do is just plug in the x and y. So 2 times y happens to be 3, so 3 squared minus 1 x happens to be 1, so 1 squared, and then y is 3. So this will be 9 times 2, 18, 18 minus 3, so that would be 16. So those are two easy examples. Now, for this example, if you plug in 1, 1, 4, so first let's plug it in and see if it's in the domain. So if we plug it in, we'll get what? 1 cube minus 4 times 1 squared, y is equal to 1 over 4, over 1 minus 4 times 1 over 4. Now you can tell this is going to be 0 over 0. So it has the form of 0 over 0. And then you look at the definition here. Every time you get the form 0 over 0, all you do, factor, simplify, or cancel the like factors, and then plug in your point xy. So how do we do that? This will be limits as xy approach 1, 1, 4. Now what can we factor? We can factor x squared from the numerator. So that would be what? X minus 4y over x minus 4y. Now we can simplify, and this will be equal limit of x squared as x approach, we don't care about y is not involved, as x approach 1, which is equal 1 squared, so it's equal to 1. Done. Again, next examples is the same thing. If we plug 1, 1, we'll get 1 minus 1 over 1 minus 1, which is the form 0 over 0. So what we do, we factor. So xy approach 1, 1. We factor x squared minus y squared. That's going to give us x minus y, x plus y over x minus y. Simplify, x minus 1 over x minus y is 1. So this will be equal limit of x plus y as xy approach 1, 1. Now plug it in, 1 plus 1, that will be equal to. Done, that's our limit. Again, same thing for this example. If we plug a 0, 0, 0, 4 minus 0, 4 over 0, 2 plus 0 square is of the form 0 over 0. So since the limit is of the form 0 over 0, we factor and simplify, or cancel the like factors. So if we, x4 is the same thing as x squared squared. y4 is y squared squared over x squared plus y squared. Now, this is, a squared minus b squared will be equal a minus b, a plus b. So that would be equal x squared minus y squared, x squared plus y squared over x squared plus y squared. Don't forget the limit. xy approach 0, 0. Now x squared plus y squared will be cancelled with x squared plus y squared. This will be equal limit x squared minus y squared as xy approach 0, 0. Now plug in the 0 for x and the 0 for y. 0 squared minus 0 squared, which is equal 0. So that's the limit. And that's it for these examples.